Hello all you zero-point energy researchers out there. I wanted to share a very interesting phenomenon here. Quite simply, we're using a piece of magnesium rod. It's a bar approximately 6 inches in length by about 1/4 inch in width. And we have a piece of gallium. Gallium is a form of lead. It's used a lot in the Mr. Hutchinson crystal batteries. It's a very shiny rock. And it only takes two very easy steps to make energy come out of this. I find it very interesting. What we'll do first is we'll put the piece of gallium at the end of the magnesium rod, right here. We'll go ahead and take a measurement of the voltage. As you can see, it's 0.0, fluctuating a little bit, 0.014. A little bit of energy readings coming out of there, but that's not the best part. What we're going to do right now is just simply apply body heat to the gallium. I'm going to put the gallium right here. I'm going to put it in my fist and let it warm up. Apply some hot air from my breath. You could either use probably like a lighter or maybe some exterior heat source, but I just simply using body heat right now. I'm just using the heat of my body and thermally warming up the gallium. Alright, now comes the best part. What I'm going to do is I'm going to place this piece of gallium at the end of the magnesium rod. So, here it goes. And now I'm going to go and take a voltage measurement. I have to bring it up because the voltage has gone up so high. As you can see, I'm getting 1/3 of a volt. 0.10 of a volt, almost half a volt now. Half a volt. Half a volt. .152. It's dropping because the gallium's temperature is dropping. As you can see, that's almost 1/3 of a volt. That's almost a constant current. And right now it's cooling down a little bit again. So the longer you leave it here, basically the more the current will go down because the gallium is cooling down. Put it back up here again. It'll start dropping a bit more. There we go, come on. Okay, as you can see, the gallium right now is almost completely cooled down, and so the current has almost gone down again. So we'll do it again. Once again, the piece of gallium, it's all cooled down now. I'll take another voltage reading, place it at the end of the magnesium rod. Go ahead and take a voltage reading. I'll bring it back down, make the voltage a little bit more sensitive. Take a reading. Okay, there we go. Now, as you can see, I'm holding the gallium against the magnesium rod. It's not easy to do, but I've got no voltage, okay? Bring it back up into view here, holding the gallium against the magnesium rod, and there's no voltage coming out right now. 0. Okay. Now we're going to do it one more time. Get the gallium, put it in my fist, warm it up. Allow my body heat just simply to warm it up. Give it some hot air from my breath. Usually hold it in there for about half a minute. That's more than enough to soak up the thermal body warmth from my body. I think what's happening here is the electrons in the gallium are becoming stimulated by thermal heat. And the gallium is a very sensitive electron absorber because, as we know, gallium is one of the first things used to make a crystal radio set, and a very simple device. Okay. All right, that should be warm enough now. I'll go ahead and put it right again. Once again, put the gallium. It's all warmed up now at the end of the magnesium. Place the probes on the end. Oh, there we go. I have to bring the voltage sensitivity down again because she's gone right up. There we go. Oops. It's not easy to do, but it's quite interesting. There we go. Let's try again. Okay, got it now. Now let's be patient here. There we go. We've got about slowly climbing up to about half a volt. Okay, there she goes. Now we're almost at 1 volt, 1 complete volt right now. As you can see, it's dropping a little bit because the gallium once again is cooling down. We're about 8.87 of a volt. There she goes. It seems to jump. It seems to fluctuate a little bit as I move the magnesium rod. But I'm applying medium pressure to the magnesium rod and the gallium. And I'm getting at least half a voltage right now. Almost a volt again. There we go. See, we're almost a volt. We're at a volt now. We're coming back down probably to half a volt. And it'll turn off again, then I'll just move the bar around a little bit more. There we go. 0.83, as you can see, it's starting to drop now because the gallium is once again cooling down. But we're still getting, you know, almost a volt now. She'll start to drop now. But as it fluctuates more and more, it'll go into a lower range. So it'll fluctuate and then go lower again. Fluctuate and go lower again. Okay, it's starting to drop again. Okay, let's just see if this is only the magnesium rod that's causing this. So go ahead, and I'm only going to test a piece of magnesium rod. Place the probes on either end and see what we get. 0. Let's try it again. I'm going to press medium firm. Once again, there is no voltage coming out of the magnesium rod. 0. Very, very little, if any. And remember, this is on the higher voltage sensitivity. Take the gallium. Maybe it's the gallium that's causing all this weird electricity to come out. Place the probes at both ends of the gallium. Once again, I'm pressing medium firm, holding the gallium in the air, and I'm getting no electric current. 0. So this proves that the 0-point energy batteries definitely have to have something that really is warmly or easily excited by electrons, or basically heat, thermal heat. Well, thermal heat seems to really increase the energy output. So as you can see right here on my meter, I'm basically at 2, which is a less sensitivity. And when I start, I'm usually here to do a test. But once I warm the gallium up, I bring it up to about a 2, because it gets so much energy that I need to make sure that I use a higher voltage setting. Anyway, you know, feel free to research for yourself, experiment for yourself. As you can see, all the leads are attached to the meter. There's no weird stuff going on here. Everything is pretty much, you know, valid here. This is just basically to hold the camera up, by the way. And yeah, research it for yourself. Check it out. Once again, this is easy3dbiz.com, coming to you live from beautiful Malibu right here. Wish you all a wonderful day. Bye-bye.